All right, 3.10, part 2. We're doing the trig inequalities today. Here we go.
In Unit 1, we solved inequalities of polynomial and rational functions. Similarly, we can solve inequalities involving trigonometric functions. Example 1. The graph of f is defined for negative 2 pi is less than or equal to x, which is less than or equal to 2 pi, as shown. What are the values of x for which f of x is less than or equal to 0?
All right, so I need my function less than or equal to 0. So it's basically like when it's equal to 0 or below. All right, and so when I'm looking at this graph, when is it equal or below 0? Negative pi over 2. So x is equal to negative pi over 2, or negative 2 pi, I'm sorry. And then when else? No. Negative pi all the way to what? All the way to 0. And so that one's an interval. And so I'm going to go from negative pi, which is less than or equal to x, which is less than or equal to 0. And then when else? This is also going to be an interval. And so then it'd go from what? Pi to 2 pi. And so now I'd have pi, which is less than or equal to x, which is less than or equal to 2 pi.
Solving inequalities is easy when we are given a graph.
Right?
If only all problems were so simple. However, we must also understand how to solve inequalities in analytical form, algebraic form. For simpler inequalities that only involve one trigonometric expression, we can often just use our understanding of the unit circle to solve. Example 2. What are all values of theta 0 is less than or equal to theta, which is less than 2 pi, for which the sine of theta is greater than or equal to square root 2 over 2?
All right, fantastic. So when is sine equal to square root 2 over 2? When is sine equal to square root 2 over 2? At what? At pi over 4. When else?
3 pi.
And at 3 pi over 4. All right? And sine deals with what? The x or the y? The y. And so basically this is saying, yo dog, when is y greater than square root 2 over 2? And so if this is at square root 2 over 2, I want it to be greater than that for my y value. And so it's on this interval right here. All right? And so then that interval would be from what? Pi over 4 to what? To 3 pi over 4. All right, and so I'd go from pi over 4 to 3 pi over 4. Now, why is this a less than or equal to instead of just a less than? Because it includes it this time. All right, so we have to figure out if it includes or doesn't include on a lot of these. All right, example 3.
All right, example 3. Let f of x equals 4 plus 2 cosine of x, and let g of x equals 3. What are all values of x in the xy plane if 0 is less than or equal to x, less than or equal to 2 pi, for which f of x is less than g of x?
All right, fantastic. So I'm just going to put f as less than g. So now we have 4 plus 2 cosine x is less than 3. Again, just like yesterday, I'm trying to get a trig function equal to a number. Now, yes, we have an inequality, but it's the same kind of concept. I need to get a trig function with a number on the other side. And so what do I do first? Subtract 4. So what do I get now? Negative 1. Then I do what? Divide by 2. And so now I have cosine is what? Less than negative 1/2. All right, so cosine is less than negative 1/2. So now I need to think about my unit circle. And so when is cosine negative 1/2? When is that happening? 2 pi over 3. When else? And at 4 pi over 3. Now, cosine deals with the x or does it deal with the y? It deals with the x. And we want the x to be what? Less than negative 1/2. All right? And so we're at negative 1/2 right here. But to be less than, we want that side. And so I kind of want this interval going on right there. And so what is that interval? We just talked about it. It's just from what? 2 pi over 3, which is less than or equal to? It's less than. All right, and so it's 2 pi over 3 is less than x, which is less than what? 4 pi over 3. Example 4.
Example 4. Let h of x equals 3 cosine of x, and let k of x equals square root 3 plus cosine of x. What are all the values of x in the xy plane? 0 is less than or equal to x, and less than or equal to 2 which h of x is greater than k of x.
All right, fantastic. So now I'm just going to have 3 cosine x is greater than square root 3 plus cosine x. Again, I'm trying to get a trig function, kind of equal or less than or whatever, equal to a number. And so now what is my first step? I first should do what? Subtract cosine. So I have 3 cosines minus 1 cosine, which would be how many cosines? 2 cosines. And then what do I need to do? Divide by 2. And so now I'd end up having cosine x is greater than what? Square root 3 over 2. All right. And so now let's think about our unit circle again. And so when is cosine square root 3 over 2? At pi over 6. When else? And at 11 pi over 6, right? And so cosine deals with the x, or does it deal with the y? It deals with the x. Now, what do I want it to be? I want it to be greater than square root 3 over 2. And so when it's greater, is it to the left of it or to the right of it? It's to the right of it. And so I want this portion right here. Now, this one gets a little bit tricky because in the other ones, we could do it like all in one shot, yeah? However, on this one, if I go from pi over 6 to 11 pi over 6, it would be the less than part. Are you following me? But I want the greater than part. But I need to start at 0. And so what is my first one? I'm going to break this up into 2 intervals now. And so I first need to start at 0. And then it goes to what? Then it goes to pi over 6. All right. Now, technically, it includes 0 because it includes 0 right here on the interval. Now, why doesn't it include pi over 6? Because it does not include on this little inequality. All right. And so that's why we do include and don't include. All right. And so now it's technically an or statement. And so then I need to go from this portion. And so now I need to go from here to here to get my other part. And so from there to there, what do we get? Not 0, but 11 pi over 6, which is less than x, which is less than or equal to, not 0, but 2 pi. I can't call it 0 because that would mean I'm going backwards. All right, and so now I need to go from 11 pi over 6 to 2 pi. All right, cool. I want to freestyle one before we keep moving. And so let's kind of put one there. And so I'm going to have sine of x, and I'm going to say it's less than, you know what, I'm going to do less than or equal to square root 3 over 2. All right, and I'm going to still do the interval from 0 to 2 pi. Okay, all right. So when is sine square root 3 over 2? At pi over 3. When else? And at 2 pi over 3, right? And sine deals with the x or deals with the y? It deals with the y. And so I'm square root 3 over 2 here, but I want it to be what? Less than or equal to. And so I want this portion. All right, I want this portion. If it was greater than, it'd be just like that top portion. I could do it in one shot. All right. However, I need to do this one in 2 intervals. All right. And so the first interval is going to go from what? 0 to pi over 3. And so I'd go from 0, which is less than or equal to x, which is less than or equal to pi over 3. Or now I'd go from what? 2 pi over 3 all the way to what? 2 pi. All right, so now I'm going to have 2 pi over 3, which is less than or equal to x, which is less than or equal to 2 pi.
And why did you say you can't do more?
Oh, no.
Solving trigonometric inequalities. To solve the inequality, f of x is less than 0, where f of x is greater than 0, we can take the following steps. Step 1, set f of x equal to 0 and solve for x. We may need the factor to solve. Step 2, create a sign chart with the solutions marked from step 1. Be sure to include any domain restrictions.
Good.
Step 3, test a value in one of the intervals by plugging substituting it into the factored expression to see if the result of positive or negative. It is usually easiest to pick a value on one of the axes.
All right, so if we can pick one thing on the axes, it's going to be a lot easier to work with. All right, keep going.
Step 4, label the remaining intervals as positive or negative. Remember, the signs will alternate if there are
the sign chart to answer the inequality from the given question.
All right, so after we do everything, we finally look at the sign chart to go. All right, let's look at example 5. All right, and so now on example 5, we have 2 sine squared theta plus sine theta is less than 0. And so on this one, what can we do to start solving? Just like what we did yesterday, we're going to factor out a what? A sine. So now I have sine theta, and I'm moving it all the way to the left because you're going to have some work involved on this one. And so I have sine theta, and then times what? 2 sine theta, and then plus 1 is less than 0. All right, and then we're going to use that zero product property just like yesterday. And so I'm going to set this sine theta equal to 0 and this 2 sine theta plus 1 equal to 0. And so now I'm going to have sine theta equals 0. And then on the other one, I'm going to have sine theta equals what? Negative 1/2. All right, negative 1/2. And so when does sine equal 0? When does that happen? At 0. When else? At pi. And technically, when else? At 2 pi in this case. All right. And so then when does sine equal negative 1/2? At theta equals what?
5 pi over 6.
No. 7 pi over 6 because it's down. It's going down. And then what? 11 pi over 6. All right, and this is where we're going to make our little sign chart. And so our end caps are always going to be 0 and 2 pi, even though they were equal to 0 in this case. We didn't actually need that. And so now we need to kind of go in order. And so pi comes first, and then 7 pi over 6, and then 11 pi over 6. All right, and so all these, I'm going to start thinking about the unit circle. All right, and so I'm going to draw my little unit circle right over here, and that's going to kind of help us work with it. All right, and so the first interval we have is 0 to pi. And so 0 to pi, I have a choice on something on my axes. All right, does everybody see how that happened? And so I can pick pi over 2 to substitute in. Okay, remember making sign charts with polynomials back then? And so now I'm going to pick pi over 2. Whenever I have an axis, I'm going to pick it. And so sine of pi over 2 is what? Say 1, which is a positive number, yeah? And then I'm going to have this to be what? 2 plus 1, which is 3. And so I got a positive times a positive, which is a positive. And so between 0 and pi, I'm going to get a positive. This next one, from pi to 7 pi over 6, we can't really use something in between there. Does everybody follow me? Because I don't know another thing on my unit circle in between there. All right? And so this is the way we need to work with it. Sine deals with what value? The x or the y? The y, yes? And so at 7 pi over 6, my y value is negative 1/2. But if it's in between pi and 7 pi over 6, it's in between 0 and negative 1/2. So it's like negative 1/4. So it's like less than negative 1/2. Does everybody follow me on this? And so then if I do that, this sine function between pi and 7 pi over 6 is going to be a what? A negative. All right, it's in between 0 and negative 1/2. It's just going to be a negative though, right? However, this part, it's going to be in between 0 and negative 1/2. So this part's going to be a smaller negative times 2. And then plus 1. So this part's actually going to become a what? A positive, all right? Because this part is going to be smaller than negative 1 now, all right? And so then I'd have a negative times a positive, which is a what? Negative. All right, this next part, I got between 7 pi over 6 and 11 pi over 6. And so am I able to use an axis on this one? Yes, so I'm going to use it. And so I'm going to pick this 3 pi over 2 thing. And so what is the sine of 3 pi over 2? Negative 1. And then what would this become? Negative 2 plus 1, which is still what? Negative 1. And so now I have a negative times a negative, which is a positive. And so now that part is positive. And so the same thing's going to occur that happened between here, which is going to happen here. And so my sine is going to be less than, so it's going to be between 0 and negative 1/2. It's not going to be quite negative 1/2, right? And so it's going to be the same thing that we did in this one, all right? And so we're going to have a negative, and then times a positive, which would be a what? Negative. All right? And so once we have developed our sign chart, now we just pick what we're supposed to use. And so this says it's less than 0, and so I want this interval and this interval. All right? And so now we'd end up with what? Pi, which is less than theta, which is less than what? 7 pi over 6. Or 11 pi over 6, which is less than theta, which is less than or, actually it still has to be less than, 2 pi. So now let's look at example 6. So now we have 2 cosine squared theta plus cosine theta minus 1 is greater than or equal to 0. This is a hidden quadratic. So what we going to do? We're going to factor it. All right. And so again, if we can factor this 2x squared plus x minus 1, we can factor this with cosines. So let's first do it with x's. All right. So what does this factor to? Two x minus 1 and then 2x plus 1. All right. And so then we'd end up with what? Instead of x's, now they're just going to be cosine thetas. So now we end up having 2 cosine theta minus 1, and we have cosine theta plus 1. It's greater than or equal to 0. All right? And so just like what we did again yesterday, we're going to set both of those products equal to 0. And so now I'd have cosine theta is equal to what? 1/2. And cosine theta is equal to -1. All right. And so when does cosine equal 1/2? At what? At pi over 3 and at 5 pi over 3. All right. And so then when does cosine equal -1? At pi. All right. And so now when I make my sign chart, I'm going to go from my end caps of 0 and 2 pi still. But now I end up having pi over 3, and I have pi, and I have 5 pi over 3. All right. So again, I'm going to look at my unit circle to kind of help guide me through what I'm doing here. All right. All right. So now I need to pick something in between 0 and pi over 3. Now, can I pick an axis on this? No. So this deals with what? Cosine, yes? And cosine deals with x. All right. Now, what is the x at pi over 3? It's what? It's 1/2, right? Now, if it's in between 0 and pi over 3, my x is actually going to be more or less than that 1/2. Going to be bigger, and so now if I substitute in, this part is going to be what? Positive, all right, because it's going to be bigger than the 1/2. So it's 2 times more than 1/2 minus 1. It's going to be greater than 0, and so that's positive. This part, it's a positive x, so this part's going to be what? A positive. So between 0 and pi over 3, I'm going to have a positive. All right, so now I have between pi over 3 and pi. I'm always going to pick an axis if I can, and so I'm going to pick that one right there. And so now I'm going to have pi over 2 going on. And so what's the cosine at pi over 2? 0. And so 0 minus 1 is -1. So now I have a negative. This part is going to give me a what? A positive one. And so now what do I get? A negative. So now I got a negative going on there. And so now I need an interval from pi to 5 pi over 3. So can I actually pick an axis again? Yes, I'm going to do an axis whenever I can. And so I'm picking that guy right there. So I'm going to pick 3 pi over 2. And so now what's the cosine at 3 pi over 2? 0 again, right? And so this is going to be what? Negative. This one's going to be what? Positive. So what do I get again? Negative. So now the 5 pi over 3 to 2 pi. So cosine deals with what again? The x. So is my x more or less than that 5 pi over 3 thing? It's more than. All right. So very similar to the 0 to pi over 3. So this part's going to be what? Positive. This part's going to be positive. So then I get a positive. So now that I've developed my sign chart, now we can answer our question. And so it's looking for a greater than or equal to 0. And so I'd end up going from 0, which is less than or equal to theta, which is less than or equal to pi over 3. Why am I using a less than or equal to this time? Because that includes it. It gave it to me that way. All right. And then or, now I'm going to go from 5 pi over 3, which is less than or equal to theta, which is less than or equal to 2 pi.